Welcome to section 4.2.4. In this section we continue talking about probabilities that aren't necessarily equal and different representations. We're going to focus on how to choose a model. And so what are some of the advantages and disadvantages of using a tree diagram or an area model? So in our first question, they gave us these two spinners. They said chance of I, probability of I is a half, probability of A is a third, and a sixth. If I put that into a table, I put one of those options, or an area model, I put one of the options down one side, so true and false. For spinner 2 I've got here, and spinner 1 I have its probabilities. And just like in the previous unit, to multiply or to find the probabilities, I multiply the sides, just like I would if I wanted to find the area of this rectangle or this rectangle with these dimensions, like these two dimensions, or for this one here, this dimension by that dimension. So I've done that here, and I've found my probability. Well, how might this look different if I were to use a tree diagram? If I were to use a tree diagram, I'd put in my values. I is 1/2, U is 1/6, A is 1/3, and then my true is 1/4 and 3/4. And remember that the way that we calculate the probabilities on a tree diagram is we go down each path and multiply its fractional probabilities. So 1/2 times 1/4 is 1/8. This one would be 1/2 times 3/4, which is 3/8. I'm going to go ahead and just multiply these out. This is going to be 3/24, and this is going to be 1/12. This is going to be 3/12. So there are my probabilities for them. Now, I'm going to tell you that as far as a logic standpoint, sometimes it's easier to follow on a tree diagram what's happening. This person had to choose I, U, or A on the spinner, had to get I, U, or A, and then these are the choices of the second spinner. This is kind of more how you would think it through if you were thinking how I'm going to do this. This one, you kind of already assume that this is going to generate all the combinations. So here you had basically 6 combinations that you can see. And here you see those same 6 combinations, same values. If you look, the probability of T and U, which is this box, is 1/24. Well, let's see. U and T is 1/24. And so, like, if I'm doing a diagram like how many coats can I wear with, if I have 3 coats and 2 ties, how many different ways can I wear them? This might be a little more logical. One of the disadvantages of the area model is it really lets you only consider 2 groups of things at a time. In this case, 2 spinners. Whereas the tree model, let's say I, U, and A, then true and false, and then maybe I wanted to roll a dice 1, 2, 3, 4, 5, and 6. I could put those here. That would be hard to put into this diagram. This diagram, on the other hand, does a lot better at combining some of the areas and making the calculations. It's a lot faster to calculate these, in my opinion, than it is to calculate this way. Now remember, if you use this, it's a good idea to put down what each of them represents. For example, this one represented T and U. This one represented T and A. This one represented T and I, true and I. This one was false for U, false for A, and false with I. And so this would help me if I have to answer the questions, like, for example, what's the probability of getting a true? Well, I would add these probabilities together, and that would give me the probability of true. Okay? Now, continuing on, we revisited the rat problem, or the mouse, and him getting to the cheese. Well, this time, we're going to say that each path is equally likely. So if each path is equally likely, here's a point of decision for the mouse. He's going to pick this a third of the time, this a third of a time, this a third of a time. Here, I've got another place where 3 paths meet, a third of the time, a third of the time, a third of the time. Here, he only has 2 choices to make at this intersection. So half of the time he'll pick this and half this. I'm going to calculate all the probabilities right now. Going this path, 1/9. This path, 1/9. This path, 1/9. So that's in the A room. Then 1/3 going straight. And then 1/6 going this way. And then 1/6 going this way. Now I can add the probabilities for A and the probabilities for B. I have 1/9, 1/9, and 1/6. I have that's for room B. And for room A, I have 1/9, 1/3, and 1/6. Let's see, these can become 18ths, just a little fraction math. That'd be 2/18ths, 2/18ths, and 3/18ths. 3, 4, 5, 6, 7. So the chances of B is 7 out of 18. And let's see, 2/18ths, 6/18ths, and 3/18ths. 6, 9, 10, 11. Chances of A are 11/18ths. And so we see here, I'm going to change them into their decimal values. 11/18ths would be 61% of the time. So we would expect him to get into A 61% of the time, and B should be the remainder. What was it? 7/18ths. 39% of the time. And remember from the story that Romeo found A 66% of the time. So the question is whether he is getting smarter or not. And the conclusion in class varied. 61 is really close to 66, but he is above it. So you could make the argument that because this is bigger than what we would expect, that he's getting smarter. Another argument in class was that these two numbers are so close together, maybe it's just a little bit off and he's just basically getting the normal probability. Some other students wanted to ask some questions, some more information, like, do we know if the probability at the beginning was a lot worse than the probability at the end? In other words, well, did he go this way like 40 something times and then all the last ones were this? Well, that would indicate that he might have some clue as to what's going on. Anyway, they gave us a modification of this one, and just to make it a little bit different. And so here it is. And if he did this and we had the same thing, equal probabilities, when he gets to this point, he's got a half and a half, a third, a third, and a third. Here he has a half and a half, then another half, another half. And so I'm just going to find the probabilities for each room and leave you to answer the questions in there. But let's see. They're making it a little bit harder. They're putting 3 rooms that Romeo has to get to. Let's see what those probabilities are. 1/6, 1/6, 1/6, 1/2, 1/2, 1/2. That would be 2 times 2 is 4, 2 times 4 is 8. 1/8. This would be 1/8, and this would be 1/4 on this path. So basically 2/6 for A. Don't have time to make this calculation, so good luck.